again, Audio Keller here, and today I have a Rockford Fosgate Punch 45.2 on the dyno, and this one is rated 22.5 watts of continuous output power into a 4 ohm load per channel, both channels driven, and 45 watts by 2 at 2 ohms per channel. I readjusted the idle current, it idles around 0.4 amps, that's okay, they have been stored for 20 years. Let's zoom to the scope and check the amplifier's output power. The first test is 1 kHz, 4 ohms per channel, both channels driven, and I apply my signal. There we have it. And as always, I go straight to the clipping point and one step below it, so we have no signs of clipping. This is clipping. I go back, take a single shot, disable my input, and use my cursor. So we have a clean 1 kHz signal. The scope says maximum 42.4 volts. I go to the top of the waveform. Yes, and we also have 42.4 volts. That means we have 56 watts of continuous output power into a 4 ohm load, both channels driven. The amplifier is pulling around 0.4 amps, that's the idle current, continuous power, and we have 11.6 amps. We have an efficiency of exactly 70%. The same test, but with a different input signal. I'm now going to use a 50 Hz signal to simulate bass continuous power. With 50 Hz the amplifier has to do a harder job. So I apply my signal and let's see what it can do. Oops, clipping. Capture it. And scope says we have a maximum voltage of 41.6 volts. And I check with my cursor, and it's true, 41.6 volts. With an input signal of 50 Hz, we still have 55.48 watts of continuous output power into a 4 ohm load. I'm hunting for some dynamic power. I test first with 1 kHz signal and 20 cycles. First I inspect the last cycle of all 20 cycles, because I want to make sure that the last cycle isn't clipping. So this is the last cycle. We can call this a little bit of clipping. Yeah, that looks much better. So I switch to the complete cycle, and you can see all cycles are at the same voltage level, and of course free of clipping. We have again, where's my cursor, 42.4 volts. Okay, we are clear in this situation. The dynamic power is the same like the continuous output power. So now I'm going to make the same test with just 8 cycles. Take a single shot, go to the last cycle to observe if there's clipping. There's no clipping in this case. I go a little bit higher with the signal input. We still have 42.4 volts. So it starts to clip in the last cycle, and we still have 42.4 volts. So there's no increase in dynamic headroom with 8 cycles. And now I'm trying to catch one with just 1 cycle. Maybe in this case we will have a higher output voltage and have higher dynamic power. So let's go and check it out. So we have clipping in the negative waveform. So in this case I will not use this one. I reduce it. Still clipping. We have 43.2 volts, so we don't have dynamic headroom at 4 ohms per channel. The next test is 1 kHz continuous output power into a 2 ohm load, both channels driven. Clipping, I go back. This looks good. stop signal input, and we have a maximum voltage of 37.6 volts. You have it here, 37.6 volts. The amplifier is doing 181 watts bridged mono into a 4 ohm load of continuous output power 1 kHz. That's 90.5 watts. Let's have a look at the efficiency at 4 ohms mono. How many amps is it pulling? 20.5 amps. Mono 4 ohms, we have an efficiency of 64.4%. 50 Hz of continuous output power. We have 36.8 volts, but my scope maximum says 36 volts, and with 36 volts the amplifier delivers 83 watts into a 2 ohm load per channel, both channels driven. That means 166 watts bridged mono 4 ohms with 50 Hz. Dynamic power test 1 kHz 20 cycles. Try to get some more voltage out of the amplifier. So you can see here all cycles have the same voltage level. No signs of clipping. In this case, the scope shows a maximum voltage of 38.4 volts. I jump to the positive waveform, if this is true. Scope says 37.6 volts. We take this value. We still have no dynamic headroom. The wattage is always the same. We have a little more than 90 watts into a 2 ohm load per channel. I tested also with 8 cycles. I have the same results like the 20 cycles test, so I switch directly to a 1 cycle test. I catch one and we have a clip-free signal and it says 39.2 volts. And I go to the top of the waveform to check out if it's true. It says 38.4 volts. I just got 4 more watts. Now I have 94.5 watts per channel into a 2 ohm load. 2 ohm mono loads, that means 1 ohm per channel. In this case, I just do the dynamic power test with 20 cycles 1 kHz. And first I inspect the last cycle if it's free of clipping. This one looks okay. So you see here we have all cycles at the same voltage level, no clipping here. And we have a maximum voltage of 31.2 volts. I recheck this. 31.2 volts. Mono 2 ohms, we have 243 watts. That means 121.5 watts per channel into a 1 ohm load with 20 cycles. Now I switch to 8 cycles. Maybe we can squeeze out a little bit more of this small beast here. Testing with 8 cycles. So we got 32 volts in this case, and all cycles are at the same voltage level. I jump to the last cycle to check if it's free of clipping. Yeah, okay. Let's say we have little signs of clipping. And we have 32 volts. With 8 cycles we have 255 watts and 127.5 watts. Test with just 1 cycle, 1 kHz, to check the absolute dynamic peak power for 1 millisecond. So the scope says 33.6 volts. Can I confirm this? 33.6 volts. And just for fun, with just 1 cycle, we have 282 watts bridged mono into a 2 ohm load, or 141 watts of 1 millisecond power into a 1 ohm load per channel, both channels driven. And let's make a test how this little buddy sounds.